You are listening to Kubernetes Bytes, a podcast bringing you the latest from the world of cloud-native data management. My name is Ryan Wallner, and I'm joined by Bhavin Shah, coming to you from Boston, Massachusetts. We'll be sharing our thoughts on recent cloud-native news and talking to industry experts about their experiences and challenges managing the wealth of data in today's cloud-native ecosystem. Good morning, good afternoon, and good evening, wherever you are. We're coming to you from Boston, Massachusetts. Today is May 19th, 2023. Hope everyone is doing well and staying safe. Let's dive into it. Bhavin, before we get into today's topic and news and guests, what is going on? How you doing?
I don't know. When you just said May 19th, I was like, shit, like we are almost halfway done with the year. And I need to go back and check my New Year's resolutions and what they were.
Because I'm toast. I'm pretty sure they were toast the day after.
I know, but like half the year. Shit. Okay, yeah. Okay, no, pick up Bhavin. Come on, let's do it. I don't know. With the weather that it has been, right? I did my first lawn mowing. I know people who listen to this pod know about my trials and tribulations.
That's right. That's great. That's big. Hey, that's big. Congrats. Big
no, I hated it again. So I think I ignored it for a month. So now the weeds have grown and they're really difficult to pull out. So I'm leaning towards getting some professional help. So if you have any recommendations for
Boston landscapers,
send them over, Ryan and all the listeners. I'm all ears.
You can make it a community project and get the local kids to come over and mow your lawn. It might not look any better, but someone
it's
will
not as big.
You.
It's just I'm very lazy compared to like how big the lawn is. So no, I need some help to at least get it in a good shape, and then I can maybe maintain it. So day 0, I need help with day 0. I can do day 2 operations.
Yeah, I saw a funny reel the other day on Instagram that was like, about people mulching and making their lawns look really nice. And it was something like, mulching, what you do to hurt your back and make your lawn look good for a day.
That's accurate. I hate those reels, dude. Like whenever you scroll by, like people's lawns looking so awesome, they have these new pavers and everything. I was like, damn it, that's so much work.
Effort, it's ton of effort. And I always felt like unless you're staying at home constantly, I don't know,
which
or
we do,
having a lot of people, like I'm out of the house more often than not. So like,
not worth it.
Keeping up with the Joneses ain't worth it. Let it grow, let it grow. It's crap. It is flying by. I know we have Red Hat Summit next week, which, we'll talk about a little bit with our guests, but, we'll both be there. That's exciting. And probably when this is out, it'll be at Red Hat Summit. So,
so if you find, me or Ryan, just say hi. I'm pretty sure we'll bring the same stickers. So we'll have some stickers for you if you find us. So for sure.
Absolutely. And if you come find us and you're interested in coming on the show, we'll do that too. We'll put something up. No worries there. All right. Well, I think without that done, I think let's dive into the news a little bit.
Yeah, let's do it. So I have a few, not announcements, but news to share. First one of the list being a new startup with a famous co-founder, I guess. So Craig McLuckie, right? He was the co-founder of Heptio. He has now started a new startup around the software supply chain security, along with the founder of the Six-Store project, Luke Hines. So both of them started a new startup called StackLock. And again, they picked up Series A, $17.5 million, and they aim to add provenance data for developers to make the whole software supply chain secure.
Again, kudos on the naming there. I'm
I know.
Big fan of naming. StackLock, it's security oriented, supply chain oriented, very good. Also, yes, famous in our neck of the woods. If you ask your grandmother, they will have no idea who that person is.
But if they're listening, look up StackLock. No, I think they didn't do a seed since the amount of money raised was so high. They just went with the Series A. So there was no seed, just Series A. They just came out of stealth, and they do have like 4 or 5 senior engineer positions open. So if you are looking for a change, there is a new startup in town.
Open positions is tough in today's market. So go get them.
And then another one was Traffic Labs. They announced a couple of things. So they announced general availability of Traffic Hub, which is its cloud native API management solution. The whole point here is you can plug and play different proxies. So Traffic's own proxy, but even Nginx, HA proxy, Ambassador, and others. So it gives you a unified management tool for your APIs, but then you can swap out all different tools based on your requirements, I guess. But yeah, and then the last one being around the security space, KSOC, which I thought was a standard because I think it's a Kubernetes Security Operations Center, but it's actually a startup. They released a new standard called Kubernetes Bill of Materials, or KBOMs. I know we have spoken a lot about SBOM. We did that with the Christopher, the co-founder of Mondu, as well. But now we have a new acronym in town called KBOM. It basically provides a quick view of scope of your Kubernetes cluster. So it gives you workload count, cost and type of hosting service, vulnerabilities of both internal and hosted images, and so on and so forth. But yeah, new standard that gives you a complete overview of what your Kubernetes cluster and applications look like. So yeah, that's news from me.
Yeah, I know SBOMs we talked about before in the context of Kubernetes, but I think this one's like designed very specifically for Kubernetes. And yeah, I thought it was like an official organization as well, right? Not just startup. Which, it's probably on purpose. It's exactly what they want people to think. They're like, yes,
yeah, we are the standard. We are the company that should be building standards.
Exactly. Cool. So I have a couple things worth noting here. 127 is sort of like frozen or something. Is it out? I forget.
Oh. No, it was out.
Yeah, that's right. And the stateful set auto deletion for PBC is in beta. So if you use stateful sets, I think this is an interesting thing where you can kind of set up auto deletion rules, so to speak, about how often those things get cleaned up after the stateful set doesn't use them and things like that. I kind of equate this to when you accidentally leave your EC2 volumes around for a while and they cost you a lot.
Yeah, they do.
They might not cost you dollars, but they're costing you something. So, of course, be careful with auto deletion. Of course, we don't want to delete your data. We don't want to do that. Some news around the AI space. I think, there's a ton of news about AI here, but I focused in on this article because it's a company called Cast AI, which focuses directly on reducing compute costs running generative AI models on Kubernetes. So I found this interesting because of, just the use case around ChatGPT and generative AI models like Bard and others are so new, and yet there's companies focused on reducing the cost to run these things. I feel like it was such a quick turnaround. Just an interesting article about how running these things and keeping the compute available. If you ever interacted with ChatGPT, you can see if you have a free one, so it's not always available. It's not easy to run these things or to make available to the masses. So I think some interesting problems as we start to adopt them more and more as a society. So pretty cool article there.
Yeah, and as we know, right, like OpenAI, like Microsoft maybe has a 49% share in OpenAI, and that's because they gave them so many Azure credits to run the service. So yes, like running these things are expensive.
Yeah, exactly. And this one's specifically to like running on a Kubernetes because that is a way in which the architectures are commonly being built. So, and
I think we covered their funding round back in February or March. Yeah. Go ahead.
Very cool. NJ, I imagine there's going to be a plethora of AI companies announcing themselves, from now until the next few years, and probably beyond that. But all right, next one is if you've used HashiCorp Vault at all, you might be, kicking yourself about managing the secrets that you use that for with Kubernetes. And they came out with an open source project called Vault Secret Store Operator. Operators are the future. We've talked about that. We've had entire episodes on operators early on, I think, in this podcast, which is probably worth another look. I've seen where operators have come from. But,
for sure.
This is one specifically that is given back by HashiCorp Vault and basically makes managing the Kubernetes secrets easier which, no one's going to, I think, disagree with making things easier. So go check that out. The next article I have is around basically using managed Kafka or running it yourself. And I know I specifically picked this one. It's a New Stack article, mostly because we've talked about running stateful workloads on this podcast a lot. Yeah. And then we've also talked about, the trade-offs of, whether you use managed Kubernetes and other managed services or databases as a service. I think this article does a really good job of sort of the thought process behind why you'd want to do something like that and what you'd have to take on from sort of like a hiring standpoint. Like you need an SRE, you need a software engineer, you need an admin, those kind of things, and kind of weighing those pros and cons and the kind of company you are. So I think it's a good article. Go check it out. Definitely worth looking at. And then I wanted to put a couple one release in here, which is Knative 110. I'm not going to go into what is in 110, but we've talked about Knative on here past. So 110 is released, and that was actually a few weeks ago. We just missed it. And
hey, that was a cold start problem.
yeah, exactly. And the last one I have on here is I might start doing this, like putting cool use cases in our news article. Anyway, cool use case of the week, I'll call it, is an edge Kubernetes deployment of robots picking fruit. It's just a very, very interesting use case around basically solving a problem of fruit not being picked in time and basically controlling waste in farming and fruit and that kind of thing. But it's Kubernetes at the edge. So it's a very, I think when I read a story about, infrastructure from a technology side about a real kind of interesting use case about solving a real problem, it always kind of connects things better for me. So maybe I'll call this cool use case of the week segment or something like that. But go check that out. Really cool article. And that's all I have for the news. So with that, we have some awesome guests today. We're going to be talking about KubeVirt. I know, Bhavin, you brought these guests to us, and I'm excited for this. KubeVirt is a very popular sort of topic today about running virtual machines in Kubernetes or next to Kubernetes or next to your container. So we're going to dive all about that into KubeVirt with Sachin and Peter. And without further ado, let's get them on the show. All right. Welcome to Kubernetes Bytes, Sachin and Peter. It's great to have you on here. Why don't you introduce yourselves for our audience here? Sachin, why don't you go first?
Sure. My name is Sachin Mullick. I work at Red Hat. I manage the product management team. That's about all things virtualization. Our primary product is based off of KubeVirt called OpenShift Virtualization. That's what we'll be talking about today.
Great. How about you, Peter?
Sure. I'm Peter Lauterbach. I'm one of the product managers here on the OpenShift team, on Sachin's team. Focus on a couple of different things here at Red Hat. Traditional virtualization or Red Hat virtualization, Rev. OpenShift on Rev, which is a deployment option that some customers use. And then OpenShift virtualization or upstream KubeVirt. In a former life, I actually did a stint at a couple of different storage companies and different startups. So I've been in kind of the virtualization space for probably actually at the time that EMC bought VMware.
Oh, okay, nice. So there's a lot of crossover here too. We were just talking with Sachin about. I was there in 2012, and I left before the Dell and EMC kind of did everything. Everybody asked me, did I know? And because I left like the week before it announced, but I did not. It just happened to be
Yeah. But it was an interesting thing. One of my buddies who I respect, and I believe he's still there, said, "Hey, we just bought this VMware thing and it's really cool." And he explained software virtual machines to me. And I'm like, sure. I don't get it. And he's like, just download, what was it? Workstation at the time.
Yeah.
Sure. Yeah.
And when I did that, and holy cow, within an hour, I had, Windows, Linux, and FreeBSD running on my workstation. It was amazing.
It's awesome. Yeah. And Ryan, to talk about, connections, right? I've reported to two of the people on this call right now.
Oh, no way. Yeah.
So I used to work for Sachin over at Lenovo. And then I know Ryan, for some period at Portworx, I did report to you. So I have two managers. Peter, maybe you're next. You never know. No, okay. So we are here to talk about KubeVirt, right? So why not start with that 10,000 foot view? Like, what is KubeVirt? What it's used for? What are some of the use cases? Let's start there, and then we can go into a bit more detail.
Mm-hmm. Okay, I can start. So KubeVirt is actually the upstream project for our product, or OpenShift Virtualization. As you know, everything that Red Hat does has an upstream community and project associated with it.
Yeah.
And what KubeVirt is actually, we've taught Kubernetes how to run KVM virtual machines. It's actually pretty simple, right? Mm-hmm. So, Kubernetes is great with containers and does all sorts of good things. And I don't think I need to explain to anybody about that. But VMs and virtualization, there's still a lot of gravity for both data and a lot of business logic that's running inside of virtual machines. Mm-hmm. And you can either have a choice of, hey, let's just leave this behind and shed it and go directly do everything in containers, which, by the way, is completely unrealistic. Or you bring virtual machines along with you, right? Yeah. And the idea of, there's a couple of different use cases, which is, hey, I've got an existing 3-tier application, database, middleware, web front end, and I actually want to modernize it, right? So I want to be able to, hit it with a hammer, put maybe a mobile front end on it, take my middleware and break it up into more microservice stuff. Sure. Yeah. That's one of them. The other one is, I have an application delivery platform that's based on virtualization today. Mm-hmm. And then I want to be able to do containers as well. You can run your container platform on your virtual platform, and a lot of people do that. But now you really have to manage 2 platforms, right? And can you connect applications across the 2? Sure, but that's like, you now own that, right? And that's your job. So now you have application delivery, say a composite application that has VMs and containers all running on the same platform. Yeah. Right. So, and we'll probably talk a little bit about the details of how that happens. Gotcha. But virtual machines in Kubernetes use all of the Kubernetes abstractions, services, routes, things like that. So it's actually very easy to connect virtual machines and containers together. And then the last one is, there are some applications that run inside of VMs that they're never going to be containerized, right? Sure. In fact, it might be a Windows.NET that, the guy that wrote it is retired and nobody wants to touch it. Yeah. And there's no need to. Yeah. And that's fine. You could just migrate and re-platform that application because it's still running a core piece of your business and run it on Kubernetes alongside. So now you have one platform that you're going to manage, but you can actually run a mix of workloads inside of it.
Gotcha. I think this falls under the teaching a new dog old tricks category.
Absolutely. Well, one of the things, if you think about it, Kubernetes is awesome with containers, but it didn't do up until recently a bunch of stuff like it didn't know how to manage metal, right? Yep. You always ran Kubernetes in a cloud somewhere. So we actually took, Red Hat as a company, we took a lot of the innovation we did for, say, Ironic, which is metal management, and we taught Kubernetes how to manage bare metal. Yep. Right. KubeVirt is the same thing. We've taught KVM is a very mature technology that's been around for 12 years. It's been in the Linux kernel for quite some time. We're just going to teach Kubernetes how to speak to KVM. Yeah. And the next one is OVN Kubernetes, OVN, right? Software defined networking in Linux runs on multiple platforms, but guess what? It also runs on OpenShift.
Nice. Okay. Those are some clearly defined use cases. Thank you for that. One thing that I wanted to ask, since we have the experts on, right? A lot of people in the community think about KubeVirt as a replacement to VMware. They're like, okay, if I start adopting KubeVirt, I can maybe go away from VMware vSphere. Is that the case? I know vendors like Nutanix and Microsoft and even Red Hat have tried moving people away from vSphere to a different virtualization stack. Do you see that happening? Is that even possible? What are some of the thoughts there?
Yeah, sure. So actually, it's a hot topic of the day. Yeah. Right. With a lot of things changing in the industry, including Red Hat actually moving away from some of its traditional virtualization products. And there's a reason why we decided to do that, because we feel the value to a customer is not in the hypervisor layer, right? So that's the value that started in the 19s, like Peter was describing with the workstation, where you become independent of your server or your desktop machine and you can run multiple of it. So if the reason Kubernetes exists is now people started seeing the value is actually coming by doing things in a more cloud native way. And it's coming from automation, declarative way of managing using the Kubernetes principles. Right. So what we are trying to do is, as Peter said, the new applications are most likely being written in Kubernetes. Like my son comes out of college, that's how he's gonna do all the stuff coming out. But this around, if you believe like the big companies that do this research, like 77% of the IT workload is still in VMs. It will go down to like 65% by 2025. So 2/3 of your applications are going to be virtual machines. So what we are trying to do is help people have a journey where they can take the stuff that's not going away in 1 year, 2 year, probably a 10 to 15 year journey, start getting familiar with the new way of doing things, because the VMs will be what they're familiar with, right? You have to do a start, stop, restart, snapshot, all the same things. The VM that somebody does still has to happen. But then you can start adding like principles like GitOps, Tekton, pipelines, and then you have a way of managing things that you never had before. So that's the journey we want people to be on. We don't think people can take their existing platform and replace it in 1 day. It's going to take a couple years, 5 years. But do they want to stick to what they have today? That's going to be probably very difficult. If they start looking 3 years ahead, they may not be making the right decisions today. So that's why we created this technology.
Yeah, and we've had a few other guests where we've talked about the topic of sort of what does the future look like, and I think in every one of those instances, it always includes virtual machines, right? Yeah. But then it also takes on sort of new technologies like WebAssembly, right, and kind of enables you to run sort of the right tool and use the right tool for the right job. I think we're seeing that trend of development teams and those kind of things want to be able to use the tools for the job. And to Peter's point before, right, you might have an application where like, don't break it, it's not broken, right? Just leave it, right? So I think this rings true. And maybe this is a good lead in to both of your previous answers, both Sachin and Peter, which is why are organizations thinking about making this move? Is it really to kind of stay up with the way the industry is going with Kubernetes? Like, do they want to have a platform, in this, new platform engineering term that we're thinking about that can support virtual machines and VMs? Or what's really the value of moving away from a tool like a VMware to something like OpenShift with VMs that, you're maybe seeing the most?
Yes, so I think we talked a lot about it, but if I have to sum it up, so the number one thing, like if you think about anything, is things start out as products and they become features over time. That's what we feel like. Now we have a unified application platform, and you can take examples from your day-to-day world, right? So you don't need to manage silos. You have just one thing to manage. So that attracts people a lot. Sure. The other one is there are like clear mandates to companies about modernizing their infrastructure, going into a cloud native world, going into hybrid. And as they look at that, again, as I said, like if they only look at greenfield applications, that doesn't give them much value, right? So that's why they're going back and looking at what exists today. And then I do feel like some of the things that happened in the industry where clearly there wasn't enough value for virtualization players just to be pure virtualization players, and they're starting to get bought out. So the companies that rely on them are getting a bit edgy. Like, am I really doing the right thing? Is this an opportunity? Like switching has a cost, right? So if I just even go from Android to Apple, it's gonna make me learn a bunch of new stuff. So why would I do that? Is for whatever reason it is, when I go to a new platform, I want to make sure I'm not just doing it just to save a few dollars. I am with something that's going to keep me happy for the next 20 years. So that's what we are seeing.
No, that makes sense, right? Like the value has to be worth it. Like the value of the new solution has to be worth it. And I agree, right? There is benefits to having a unified platform where you can manage VMs and containers and follow these new principles that you guys discussed, right? Like if I want to use GitOps for my new applications, why not try to implement some of that into my virtualization layer as well and see if it works for my VM workloads. But okay, so now let's go into those details that we promised.
If I could expand on that a little bit.
Please.
It actually is about how you use it, not about the technology, right? Like anybody that thinks, oh, I'm going to run VMs and containers and my life will be better. Like, take your hands off the keyboards.
Yeah, exactly.
But let me give you a little history lesson, right? Which is agile software development for developers has been going on for close to a decade now, right? It started with Maven and Gradle and, Java-ish kind of stuff. But the idea of a fast iterative loop, that's been around for a while now, right? Mm-hmm. Kubernetes just makes it easier. So all the software developer guys have had these benefits for, over a decade now. The infrastructure people are stuck with pretty much what they built by hand.
Yep.
In their vSphere environments, right? Which, yes, there are other virtualization platforms and technologies, but let's face it, right? Like that's the standard. But now, okay, I want to use a declarative way to roll out, using something like zero-touch provisioning, which is the ability it's essentially GitOps to roll out hardware, which is right now it's all telco and edge stuff. But you know what? You can use that same technology to lay out a rack full of data center and, everything's declarative. It doesn't drift. And if you want to change something, you check code in, it gets reviewed and automatically tested and rolled out.
Yeah. And I
that's
think
a different way. That's a different way of operating.
Yeah.
I absolutely agree. And I even would say we've seen a trend with a lot of newer startups that are kind of taking both the infrastructure piece and the software piece now and kind of cramming them together in a single abstraction where, they basically let you point at what you want to deploy and they'll go ahead and take care of everything from, zero touch provisioning to deploying your app as well instead of a single sort of control plane, which, really just drives, I think, at, again, the goal of faster loops, right? And ultimately, to your point, it really comes back to still how you're organized yourself as a team, right? And culture and being able to support that kind of rollout.
Right. And let me use the example of releases, right? It's not just faster loops, it's smaller increments, right? Which is a traditional virtualization platform, your life cycle, major releases are every 18 months to 2 years. And a couple of months in between patches, right? Something like Kubernetes used to drop 4 times a year, and people are like, oh, okay, can you slow it down a little? Right, so Kubernetes drops 3 times a year. And then on the OpenShift side, we do Z streams weekly, right? So every week there's, there's a dozen bug fixes in this, and you can take them or not. But yeah, just rolling forward on an incremental basis is literally implicit to the platform.
Yeah.
Makes sense. Okay. So now let me get into the details. Like I know we promised our listeners that, right? So how does KubeVirt actually work? Like we all know that it runs on Kubernetes, but does it have its own custom resources or CRDs available? Does it run as a pod or there's a new VM object like Peter or Sachin, like, can you talk about like how it actually works?
I can. So, and this is the interesting part because people are like, well, KVM VMs and pods and all that. Do I have to create a container? No. So virtual machines in Kubernetes are good citizens of the Kubernetes platform.
Okay.
Right. So they're first class objects. Yes, we do use CRDs and we use an operator, but you operate on virtual machines. You say, create a VM from a template, put these kind of disks in it, set it this kind of memory. Everything is familiar to you. And then the Kubernetes stuff happens underneath, right? So let's use 2 basic examples, right? How do you get your storage?
Yeah.
In the old world, let me compare and contrast. You would get a massive LUN from your storage team. You put in a ticket, a couple of weeks later, you'd get this LUN and you put it in, and then you'd put a data store on it, right? Mm-hmm. And now you as the admin have to pay attention. How many VMs do I put in that data store? Am I running out of space? Is it performant enough, right? That's barbaric, right? Like, I don't want to do that. I just want to manage.
I was going to say, I think people are cringing at the fact that you said 2 weeks later you get your LUN.
Well, actually, I won't name the company. We've had a customer say to us, "Look, mm-hmm. I need you to be able to zero this out when I want to, when I unallocate it." And we're like, "Why? Just destroy it?" He's like, "No, because once a storage team gives me the LUN, I never give it back to them. Yeah. I just have to wipe it out and then I reuse it." Like,
it becomes your pet.
Yeah, like, okay, so you want me to put in a product feature because of your organizational deficiency?
That's a good one there.
So now let me tell you how it does work in Kubernetes. Kubernetes actually has a very strong storage abstraction called CSI, the Container Storage Interface. And what's very cool about that is it's a set of APIs and definitions that say, okay, here's how you provision storage. You get persistent volumes, and you get them through persistent volume claims, right? So in our world, it's a one-to-one relationship. So every virtual machine disk is a PV that's claimed through a PVC, and you don't have to worry about it, right? You get that it's right? Kubernetes is self-service, right? So I go and I instantiate this virtual machine. It will go request it from whatever storage classes. And this is the other cool thing. Kubernetes has this idea, which, if you compared it to something traditional, it would be like storage-based policy management, which is, it's declarative. Tell me, is this fast storage? Is this bronze, silver, gold? How often is it backed up?
Right.
Well, Kubernetes has that. You say, let's use an example, say a Dell array, right? Where you say, hey, and by the way, there's like many to choose from, but let's just pick one like a PowerFlex, which is the new software-defined stuff, right? You can go create a couple of different storage pools within that and expose them as storage classes in Kubernetes. And then when you create your VM, we'll either use the default one or whatever storage class you tell us.
Yep.
Now, a couple of things happen there. One is storage is no longer your problem as a VI administrator, because how much capacity is in that storage pool? How is it replicated? How redundant is it? How is it backed up? Like, that's not your problem anymore. There's a professional, that's managing the storage part of the Kubernetes cluster. Right? You as a VI admin don't have to worry about any of that anymore. So networking is let me finish on the storage side.
Yeah.
So there's really two classes, right? One is your traditional vendors, right? NetApp, Hitachi, Dell, Hewlett Packard, and gosh, I'm probably leaving somebody out, but all of the traditional array vendors have CSI operators and drivers that connect directly to their storage, right? So iSCSI, Fiber Channel, NFS. And that's one class, and they work fine with virtual machines, right? So KubeVirt does that. And then there's another class which I would consider cloud native, right? And that could be something that either runs inside the Kubernetes cluster, right? Like say Portworx, or LinStore. There's a couple of Storage OS is another one. And then OpenShift Data Foundation, or you can actually have an external cluster like an external Ceph cluster that you can expose storage into.
Sure.
Once you make those connections into the Kubernetes cluster with a storage class, you can expose request volumes from it directly. So networking is very similar, right? So there's actually multiple choices for networking, right? So
sure.
On the OpenShift side, right, you can use the OpenShift SDN, which was our default up until a while ago. Now we've released OVN Kubernetes, right? Which again, that was essentially the networking stack from OpenStack, but it's very capable. It's now the default for OpenShift. right? And you can deliver and plumb your virtual machines into that. The very cool part is Linux networking is very capable. And in the past, a lot of IF config and it was just messy, right? And at some point, somebody said, hey, we should make this declarative. And this was even before Kubernetes. Mm-hmm. And they said, we're going to create Network Manager, which is exactly that. It's a declarative way to say, I take these physical things that you find and carve them up this way, VLANs, bridging, bonding. It's all declarative. And it turns out there's actually an operator for that, right? So you can actually teach Kubernetes how to lay out, how to use Network Manager to essentially configure your entire network in the cluster, right? And if you don't like either one of those, you can pick one of the CNI vendors, right? So let's see, there's Cisco ACI has a CNI interface, Tigera Calico, Isovalent, Thilium. And this is the cool part is like, now that you buy this thing, they all have integrations into Kubernetes. You don't have to do it. You just go into the catalog, download the operator and tell it how you want it to configure it. And boom, your Kubernetes can speak, isovalent.
Mm-hmm. I know that's the great part about having standards, right? Like you spoke about the CSI standard. As long as every vendor complies with that, it works out of the box with not just pods, but also KubeVirt VMs. Same thing with CNI. As long as you are compliant with the CNI standard, you can bring in your Calicos or Cilium meshes. And then if you wanted to I didn't know Cisco ACI had a CNI plugin. So that's something new I learned today.
They absolutely do. And now the interesting part is the virtual machines are part of the Kubernetes end-to-end testing. And some of the testing is more complete than others, right? So in the CNI testing, we actually spin up 2 VMs and we connect them together. The storage one, we need a little bit of work there. I do want to touch one more thing on the VM part.
Sure. Yeah.
So the interesting part is KVM is super capable, right? You can create a VM with hundreds of vCPUs and terabytes of memory and, stick something like SAP HANA inside of it. You can do that on multiple Red Hat platforms.
Yep.
Those capabilities exist on OpenShift, right? So from a performance point of view, for a similarly configured hardware, you should expect performance parity for running something like on RHEL or Rev, right? And then if you need to do anything like, I've got a fat NUMA server, right? And I've got a database that I want to map it across a couple of different NUMA zones. You absolutely can do that as well. GPU enabled stuff. You got big fat GPUs in your servers that you want to connect to your virtual machines. You can either do that directly through PCI pass-through, or there's actually a vGPU operator that can actually slice up a big fat GPU into different virtual machines. So a lot of the capabilities, the KVM capabilities that exist on other platforms also exist on OpenShift.
Got it. Yeah, that's super powerful. And I want to take a stab at sort of reconnecting all the dots that you just laid out for us a little bit. And you correct me if I'm wrong, but KubeVirt as a technology QEMU, that gets basically installed to the base nodes, right, where applications are going to run. And then you have a networking and storage component. That networking, as you said, allows the VM to communicate with other containers, get hooked up to services in OpenShift or Kubernetes and that kind of thing. And then the storage component, I'm guessing, has both sort of the concept of a root disk, which is like your operating system, and then sort of potentially also using the same CSI components for a data disk. So if you had an application in your VM that needed space to write, that you had those components. So there's sort of an infrastructure piece that is installed, and then you have sort of the networking storage components that are kind of also tied together with OpenShift or Kubernetes. Does that sort of sum it up?
That's exactly right. Let me make a minor
please
technology change here. So KubeVirt requires bare metal servers. So what actually happens is, just as RHEL is a KVM hypervisor and Rev is a KVM hypervisor and OpenStack is a hypervisor, all type 0. The the Kubernetes node running on bare metal is the hypervisor. So there's nothing to install, right? Linux already knows how to run VMs, like that. Right. Comes that way out of the box.
Yeah.
When you install the KubeVirt operator, what you're installing is the CRDs and the APIs to actually manage and create VMs on that platform. But the actual technology to run KVM is literally baked into the Kubernetes node.
Right.
Gotcha.
Makes sense.
Okay. So talking about, like, I'm glad that you brought up terms like NUMA zones, because I'm pretty sure like VMware admins that have gone to VMworlds for years definitely will feel more comfortable now that you have listed those technologies, especially the vGPU operator and splicing up your GPUs. That is awesome. My one small follow-up question was, does this support all guest OSs? Can I do Windows Server? And I know obviously we can do Linux based, but my question was around Windows Server, right? Like, can we bring on those workloads as well?
Absolutely. So KVM can actually run Windows, Linux, RHEL, Ubuntu, CentOS, whatever flavor you want. It'll run there. The only, I wouldn't say trick, but the only thing you need to remember is QEMU actually supports two different machine types. There's the older i440FX, which I don't know why I named that, but it's.
But we'll put it in the show notes. Don't worry.
KubeVirt actually only works with Q35, which is a more modern virtual machine hardware type.
Sure.
And that's what you want to be using anyway. So as long as you can deploy install your operating system on Q35 machine type, which the answer is almost always yes.
Yep.
You can run Windows. Now here's the interesting part. Windows or at Red Hat, we validate the platform as part of OpenShift, right? Yep. So we actually go through Microsoft has a validation program. It's called the Windows Server Virtual Validation Program, SVVP. And we do that for every Red Hat platform. So RHEL, Rev, OpenStack, and now OpenShift. So we run through that entire test suite in Windows VMs on OpenShift. They all pass. It's actually a release criteria for us.
Yeah.
Passes, and you can actually go to the Microsoft site and say, look, OpenShift is validated. And what that means from a commercial point of view is, as long as you're running Windows Server 2012 R2 and later, and you have a problem with it, and that's like, SharePoint, SQL Server, Windows desktops, 10, 11, you have a problem, you can either call Microsoft or you can call Red Hat, either one, and you're fully supported.
Got it. Yeah, awesome. That is very powerful. And I feel like, the more that we get into this, the more it starts to feel like, that you could easily see this as a reason, right? If you were on the edge before of should I be running VMs in my Kubernetes infrastructure or OpenShift infrastructure, it sounds more and more like something I'm used to, and sort of like if I was a VMware, sort of used to using those. And I think on that note, since we haven't kind of dove into sort of the beyond day two or sort of, the basic use case is, if I'm used to using sort of vSphere and things like vMotion or vSphere HA, how do, the OpenShift and Kubernetes sort of KubeVirt integrations line up with those types of features that might be seen as sort of, advanced, topics?
Right. Well, vMotion or live migration is not advanced. It's actually literally it's table stakes for a virtual platform.
Sure.
Right?
Sure.
If you can't do that, like, you can't call yourself a virtualization platform.
That's fair.
But as most people say, hey, but if you're running a pod on a host and you want to run it somewhere else, you don't move the pod. You just kill it and start it somewhere else. So we actually do that for you. Right. Remember when I said all of the Kubernetes-ness is handled for you? So you say, hey, I want to migrate this VM from this node to that node. We'll actually start, and it's the same technology that you use on other platforms, right? We will start a pod on another target node, and we will start streaming the running VM and the memory over there.
Yep.
You'll need shared storage, right? So you need to be able to connect the PVs on the different hosts,
Mm-hmm.
and we'll stream it over there while the VM continues to run. So this is how live migration works on every Linux platform.
Yep.
And when you're ready to go, and all the memory and data is over there, it's converged, then we'll actually stun the VM, start running it on the target system, and then delete and disconnect the pod over there. And obviously the storage is moved over, right? So the QEMU KVM process is the piece that handles the actual mutex of who's writing to the disk.
Yep.
So the cool part is I've just described something that's actually incredibly technical, but you can migrate multiple VMs at a time. You can monitor their progress. You can cancel a migration at any time. But again, in Kubernetes style, you as an admin don't need to worry about that. So say I want to upgrade my Kubernetes cluster, right? And over-the-air updates will automatically roll out through your cluster. The Kubernetes upgrade operator will go, hey, I need to cordon off and drain this node, right? And every VM will get a notice like you need to be running somewhere else, right? And as long as the live migration, the run strategy is set to live migrate, it'll exactly start doing that in batches if you wish. And then when all the VMs are drained off of that, it'll upgrade that node, reboot it, and it'll come back up and rejoin the cluster, right? And you'll do that through every node, every worker node in your Kubernetes cluster.
That's awesome. I think
it's a good citizen of the Kubernetes platform.
To prep for this episode, right, I was going through and ask an OpenShift admin YouTube stream, and they did an episode on KubeVirt, I think 2-3 months back. And the one thing that I really liked was live migrations can also be defined through YAML files. Like I can have, is that correct? Like, yeah, okay. So I can have the VMs and then tell them, okay, this is when I want to live migrate. So I don't have to go to the UI. I can still keep using the Kubernetes constructs and my favorite YAML files to do live migrations.
Right. And we sort of skated past the, what happens when a Kubernetes worker node fails, right? A physical host goes down, right? So we've actually built technology into Kubernetes to do this that normally Kubernetes takes like 5 minutes to figure out that a node's not responding. Well, that's not quick enough for VM workloads, right? Like you got a database that people are waiting to get into, right? Now the thing's down, right? Because the VM is not running anymore. We actually have an operator that will detect the node is down. It will fence it, make sure that it's powered off or, disconnected from the cluster, and then restart those workloads elsewhere, right? So usually within 60 seconds, again, it's the same, failover technology that we use on platforms like Rev and OpenStack, just running on a Kubernetes platform.
Gotcha.
One other thing I did, we kind of skated around the storage thing too. Ryan, I think you mentioned this. This is something that's kind of cool and different, and I think it's worth mentioning.
Sure, please.
So normally, you as an admin would go build, I have golden images and I build them, and, I got a process. I have PowerShell or Python script that does this, and it puts it in a data store, and I do stuff with it. Sure, you could do that with KubeVirt. But we actually have something a little more clever, right? We actually can create virtual machine templates that have boot sources that exist in the cloud, right? So like RHEL, there's actually RHEL images that are in the cloud, QCOW2, that you literally free and downloadable anywhere.
Right.
So you say, okay, I want to use that for my boot source. And what will happen is we'll go create the template, we'll download the cloud image and make it available to the cluster. And every VM that you build for that template will use that latest image. Then there's a cron job that we create that runs in the background and checks, to see if that image is updated. And if it is, like say you're running RHEL 9.0 and 9.1 comes out, we'll go out and we'll grab that. And we'll ZStream comes out for a RHEL image. We'll grab the updated image, update the boot source, and then any new VM that you create from that template will automatically get the updated boot source without the operator doing anything. It's a self-service platform.
Yeah.
Very cool.
And so all of this catalog that you have built, does it have to be on customers' premises or customers' OpenShift clusters, or only the images that they need can be pulled down as these boot volumes?
You can do it either way, right? You can bring everything down and cache it locally, or if you've got a strong enough and a redundant enough internet connection, you can leave them up there.
Gotcha.
Our experience, though, is most customers, especially in the financial and government places, either use a proxy because they don't allow their Kubernetes clusters to talk to the internet.
They shouldn't. Yep.
Yeah, that's actually better that way. But OpenShift itself has the ability to create a local mirrored cache of everything that's up on the internet. So you go create that. That's now disconnected from the internet, and you can deploy anything based on that.
Okay, gotcha. And since you hinted at customers, right, that brings me to my next question. Like, are there any case studies or success stories that you can share where customers are using VMs on OpenShift in production and running this container plus VMs side by side on the same infrastructure stack?
So I think this is a very appropriate question because we have Red Hat Summit coming up.
Yeah.
And Red Hat Summit, actually, we have at least 3 sessions that are focused on OpenShift virtualization. So Israeli Ministry of Defense is going to talk about their implementation of their private cloud with 20,000 plus active users. They needed a 5.9 uptime. And the reason they went here is to increase reliability through automated processes, component decoupling, and then implementing their governance. So a lot of stuff that Peter just mentioned to you, customer actually is going to talk about that. We have a customer on the edge front, National Oceanic and Atmospheric Administration. It's much easier to say NOAA, but not every. So they analyze weather data to help pilots know when it's safe to fly. And of course, you get all these Twitter alerts and all. So they have like 150 clusters. They're moving them to OpenShift virtualization. Cool. They'll talk about that. Morgan Stanley has talked about previously about OpenShift virtualization. They'll continue to talk about where they're on this journey on the unified application platform. And then public reference on our website itself. We have a very interesting customer which has an online classified site called Sybindin. And people in US may not have heard about them because they're based out of Turkey, but they have like 58.1 million monthly active users from the last time they reported when they did the case study.
Yeah.
And 12.7 billion page views, 5 million active listings. So it's kind of like a eBay plus Craigslist combined. And they are like a 24/7 operation. So they moved their whole 3-tier application onto OpenShift virtualization. And now they're actually taking their front end. So the stuff that Peter was talking about, you take your front end and containerize it. It's actually happening. So that's actually one of the things which we did want to talk about a little bit is we talk about containerizing as the reason to go to OpenShift or to Kubernetes. That's not necessarily true, but it's also possible, right? So if you're doing change management, easy stuff may be either to completely rewrite the application or lift and shift. So OpenShift virtualization, you can think of it as a lift and shift operation. You know it works, just get it in there. And if you are like not feeling like doing anything more, it's still going to run as a VM. But if you really think you want to add more agility to your processes, like you want to change your shopping cart on a periodic basis or something by adding containers in there, it's all free game at that time, right? So that's some of the advantages people get going this way.
Yeah, absolutely. And I was going to say, if since you mentioned Red Hat Summit, I know Bob and I will both be there. Will you both be there as well?
Yeah, Peter is actually based in Boston, so he'll be there, and I'll have another person. So yeah, definitely catch up. And again, we are working with all our partners, and both of you are in companies we love. So
there we go.
Yeah, I'll definitely be there. It's what the beautiful Boston Seaport District.
Yep.
but it's going to be long days, and where they're actually OpenShift Commons is actually on the Monday.
Right.
Mm-hmm.
If you can find me there, or we'll be all through the different sessions. There's actually a lab going on too. So this is the other thing that's important. When we talk to customers about this, they still, okay, yeah, you convinced me, or, oh, those are beautiful slides, but I'm still not sure. The best way to do this is to get hands-on with it.
Yep.
Right now.
Yep.
Okay, great. Now I need a bare metal Kubernetes cluster. No, not really. So there's actually something that Red Hat has built. It's called Kube by Example.
Mm-hmm.
Has these different learning paths in it, and one of them is KubeVirt. Right. Okay. So again, everything that we do has got a strong upstream component and is freely available for anybody to use. So you can come up to KubeVirt and participate as much or as little as you want. The other contributors and adopters you'll see up there, like NVIDIA and other what people can consider competitors to Red Hat, like SUSE, the Rancher, the Harvester folks are there too.
Yep. Nice.
Absolutely. All right.
Yeah.
Well, I do have one more question before we can dive into sort of the community, where people can find more and that kind of thing. But since you are coming at it from sort of a Red Hat perspective, we talked a lot about KubeVirt and what it is, but maybe we can talk about the differences between what is KubeVirt and what is OpenShift VMs.
Mm-hmm. Yeah, so it really is upstream project versus downstream product, right? Mm-hmm. The basic one is that Red Hat is doing all of the integration and testing of the full OpenShift stack, right? So it's not like, hey, I could go download this Kubernetes thing and now I got to go build it myself. Sure. And by the way, we have customers that do the do-it-yourself thing, and they're actually quite good at it. But the thing you got to remember is it's not the building it that's the hard part. It's the keeping that running for 3 to 5 years and upgrading along the way. Red Hat takes that part. So all the certification for RHEL and the Windows Virtual Machine, that's built into it. The one thing that you will find in OpenShift that is not going to be an upstream KubeVirt is OpenShift actually has a fairly capable and competent web console. So it's actually it's a UI that you can manage all of the things in OpenShift that I just described, right? Workloads, pods, network, storage, and virtualization as well, right? So a lot of the panels and UI that you're used to, both in vSphere and Rev, we've actually replicated a good part of that, the useful parts of that, in OpenShift.
Got it.
Yeah, and
that makes sense.
Believe it or not, like I was using that today, and like I could really connect the dots when you were talking about certain features as I was going through it today. I am still having some issues, so I might reach out to you, Peter, but overall
that's fine too. And actually, one of the other cool things about the web console is there's this dynamic plugin concept. So probably the best analogy loosely is sort of the vCenter plugin technology. So I know there's other companies and ecosystem partners of Red Hat that are building their own plugins that manage their storage and networking that plug directly into OpenShift.
Got it. Makes sense. And speaking of getting help or contacting someone, I know we talked about us being at Red Hat Summit, and you'll be involved there. I know you mentioned Kube by Example. Are there other communities? I know I've seen KubeVirt.io, and there's a community there. What other sort of resources and sort of communities or events can people find more information at? Sure.
The KubeVirt.io is obviously the place to land. There's a couple of things there, right? You'll find obviously all the code and all the maintainers and stuff. But we have an annual KubeVirt Summit, right? Which actually runs alongside of KubeCon. Actually, no, I take that back. It actually usually comes right just ahead of KubeCon EU. So that's literally, it's like KubeCon, but it's all about VMs, right? And everybody like NVIDIA shows up. Hey, let me tell you about all the cool new GPU stuff we got going. There's a lot of performance and scale stuff that goes on too. So that's, the KubeVirt Summit is, and those are all recorded too, so you can look at them later. KubeCon itself, which is a massive conference, there's always at least 3 KubeVirt focused things there. And it usually it used to be just like, hey, let's tell you how cool it is to run VMs in Kubernetes. And now it's really morphed into VMs and something else. Like, hey, let me tell you about virtual machines and service mesh or virtual machines and pipelines, using Tecton, right? It really is. If you're just talking about VMs and Kubernetes, that's kind of the boring part.
That's the goal, right? Like we want to make infrastructure as boring as possible.
Exactly, right? So the other resource I can think of is Kubernetes itself has a Slack channel that's open. Yeah. And there's a virtualization channel in there, which is where all the KubeVirt folks hang out. Mm-hmm. And then the Ask an OpenShift admin. Yeah. Right. So that's again a Red Hat streaming property, but Andrew, very graciously lets us come on there every couple of months and talk about what new cool stuff is going on. And it's fun because you get to watch what's happening and it's not just, hey, let me show you how to do this, but like stuff kind of often breaks in there and you're like, well, how do they troubleshoot this? And then you can see us go through stuff. And then I think actually as part of KubeVirt.io, there is a KubeVirt Devel mailing list. I can't remember the exact name of it right now, but there's plenty of ways to get into it.
Yeah, if you send us the link, we'll include it in the show notes.
Okay, we can do that.
Yeah, we'll definitely do that. Well, I think that's about the time we have today. I know we covered a lot of ground today, so I appreciate you both, coming on Kubernetes Bytes, talking about KubeVirt with us. I know it'd be great to see you next week. Next week when this airs, it'll be this week. So it'll be great to see you at Red Hat Summit. I hope we do. And just with that, I want to thank you for being on the show. Appreciate it.
Can I actually tease one last thing that since we're under, strict confidence here, everybody on the internet's going to be able to see this. What we've talked about today is, and what most people think about with KubeVirt is, hey, I run user workloads in a Kubernetes cluster. One of the other things that's been kind of challenging for OpenShift is running on different virtual platforms, right? And it can do that, right? You can run OpenShift on vSphere, OpenShift on Rev, OpenShift on OpenStack. We've got a capability that we actually announced in the last what's new in OpenShift 4.13, which is hosted OpenShift clusters. And what this is you've got a bare metal cluster, and then using hosted control planes, you can actually spin up individual OpenShift clusters that run inside of virtual machine worker nodes. Right? And now you can actually take a big fat server and slice it up, and basically clusters now become cattle themselves, right? And I can give this dev team their own OpenShift cluster and that dev team their own OpenShift cluster. It's a pretty powerful concept. It's in tech preview right now, but look for it to be GA as soon as we can make it so.
Okay, so one follow-up question there, right? These OpenShift clusters that you are deploying on VMs, do they spin up their own control plane, or is the control plane shared across all?
Each one has its own hosted control plane, and hosted control planes are we could have a whole nother hour topic on that. But right now, what you need to do is, if you run OpenShift on a virtual platform, you create 3 VMs and shove a control plane in it. Hosted control planes those now run in pods, so they're much smaller and more efficient, and you can actually run them in different places. Right, so I can actually take a central management cluster, run multiple sets of hosted control planes on it that are all pod based, and manage multiple node pools of bare metal workers alongside it. Nice. And the cool thing is that it's much faster, right? So spinning up an OpenShift cluster on bare metal, it's about an hour, 50 minutes.
Yeah.
Spinning up a hosted cluster, 10 minutes.
Oh, okay. That's awesome. Like not just for the amount of time that you will save, but also the resource utilization, right? That goes up because now control plane is running in pods. So thank you for sharing that.
That's right. And the other benefit is, that multi-tenancy of I can give a dev team their own cluster and they can have their own RBAC access to it, right? I don't have to give them access to the bare metal cluster, but if they go in and they hork something up because they did something stupid, I'll just give them another cluster. Yeah. Not that ever happens. No, developers never mess up anything that you give them.
Never.
No, okay. No, I guess to continue Ryan's thoughts, right? Like, thank you so much for being on the podcast. This has been a great episode. Like, we went into so many different kinds of details. So I'm sure our listeners will appreciate it as much as we do. So thank you both.
Thanks for having us.
All right. Well, that was a fun conversation with Sachin and Peter. I know it's something that I feel like I've been really wanting to dive into more and really get more hands-on. I've used it a little bit, but not nearly as much as I want to. What did you take away from it?
No, that was a good conversation, right? Like, again, we started with the premise that, are people really using this? And then obviously at the end, they're like, this has enough features that people are using, like people are already using it, and people who are not are evaluating it and will end up using it. But I think my one key takeaway was, or like one of the many was, organizations that are looking to modernize and start using Kubernetes don't have to worry about modernizing their whole application stack or whole estate, right? Like, they can maybe modernize 10% of their applications right now, but they can still move or migrate everything over to Kubernetes or OpenShift. And then maybe gradually, maybe in the next 2 or 3 years, they can modernize the whole stack. But right now, this gives them that unified control plane. This gives them all the features that they were used to in their previous virtualization stacks. Many of them Peter listed out during the pod as well. And like, allows organizations to take their time. They don't have to rush into these things and adopt technologies that they might not have expertise around. So that felt like a good solution to have. And I think the second takeaway was like all the different features that Peter spoke about, right? Like the NUMA zones, the vGPU operator from NVIDIA, allowing GPU slicing. I know in the VMware ecosystem, which again, I used to work with a lot, those were like really important things that VM admins or virtualization admins needed. Like, you couldn't dedicate an entire GPU to a single VM. So VMware built that technology over years, and having that technology already built into OpenShift virtualization. I'm not sure about KubeVirt. I don't know if Peter highlighted that, but yeah, having that already built in, that really helps people ease their mind. Like, okay, the features that I expect are already available, so I can think about moving and not be worried about running these things in production. So those were some of the takeaways that I had. What about you, Ryan?
Yeah, I think building on top of that a little bit, right? The part where we talked about not changing a workload if it's not broken, right?
Yep.
Having the ability, like you said, to kind of slowly move things over. It's not like you have to lift and shift everything you have in your VMware infrastructure over to OpenShift, but or just KubeVirt and Kubernetes. Yeah, but you can take something like a old .NET application that the guy's gone. I think Peter said no, it doesn't. No one knows how to maintain it, but it's still working, right? That's a perfect example of like you can move it over. You get all these enterprise features like live migration and failover and those kind of things where you can keep things ticking along if you are modernizing that way or are moving your infrastructure and things like that. I think that's a really powerful piece of it. The other part, the key takeaway that I got is it's not like this technology is really that new. It's really been trusted, right? QEMU and KubeVirt has been sort of, the back-end technology, the pieces that make it tick have been around for a long time, running virtual machines on Linux and things like that. So it's not a net new technology that I think people have to put their faith in. It's more or less like it's enabled now, as it always was in Linux, just through the Kubernetes ecosystem, right? And I think that's a really powerful piece of it in sort of allowing yourself to kind of trust and use the workloads that way. It's kind of Linux has always been there, so it's really just the pieces are there, and we connect your networks, through CNI. We connect stores through CSI. We have all these pieces that we're just kind of plugging together. It's more involved than that, 100%. I'm simplifying it way overly, but the point is that I think that whole piece of it makes, I think, the trustworthiness of it. And sort of the ecosystem really being able to move fast. I feel like this whole idea of running VMs on Kubernetes was something I felt like I was talking about as something new, and now I feel like it's come to the point where it's like, no, we're just doing it, right? Yeah, it's moved very fast, so that's really exciting.
And I think the sessions that Sachin highlighted for Red Hat Summit, right, or the customer case studies like Morgan Stanley and Department of Defense in Israel, those guys are doing it in production today. So like, I'm excited. Like after recording the interview section, I think I went back to my session catalog. I scheduled those sessions. I want to see what their challenges were and how they overcame those challenges. So again, great stories, a great piece of technology. I love how it interoperates with Kubernetes already, like with CSI, CNI. So I don't have to change anything. I don't have to change my networking providers. Don't have to change my storage providers. Everything just works. And
yeah, there you go.
Yeah,
exactly. Well, you know what? Well, maybe if we go to the sessions, we'll go snag them and see if they want to come on the show and talk about
for sure.
No,
let's do it.
I would love that. All right. One thing we forgot to do, this is Bhavin and I's fault, was we forgot to do our ChatGPT question of the week. And we're just going to do it here live with us. And so the ChatGPT question I asked basically for it to come up with a question based on sort of, Kubernetes and containers, a fun one. We always do fun. We don't want to do boring. So the question it came up with was, if virtual machines and containers had a talent show, Bhavin, what unique skills would they showcase? And who do you think would win?
Okay, so I have not looked at the answer, right? My guess would be like, okay, I don't want to talk about their individual skills, but they were both popular bands on their own. Now you get to see like one show where they both perform. So I think that I'm excited for that piece. I don't know what ChatGPT responded around talent.
Nice. You're saying it's better together. Nobody wins. It's a tie. You're very fair. I like
from
that.
a user perspective, I'll have more fun if both of them are performing together. Right? I don't have to buy two tickets. I don't have to go to two different venues. That's it for me.
Like, give me a hockey game and a baseball game at the same time. Let it happen. Totally different seasons, but we're working on it. I just pictured the hockey rink inside of Fenway. Anyway, moving on. ChatGPT answered its own question, and it says, in a talent show featuring virtual machines and containers, each would showcase their own unique skills, and here are some possibilities. So it does go into unique skills. Okay. Virtual machines might exhibit their talent for isolation and security. They could demonstrate their ability to create complete and independent operating system environments, juggling multiple applications effortlessly. Their talent would lie in maintaining strong boundaries and ensuring the stability of each virtual instance. Pretty fair assessment there. And then it says for containers on the other hand would flaunt their agility and efficiency, and they could display their knack of rapid deployment, quick scaling, and resource optimization. Their talent would be in seamlessly packaging application dependencies, allowing for easy portability across any environment. Also, pretty valid answer.
I'm visualizing like an opera show going on with like strict rules and like a conductor guiding everything, and that's for VMs. And then containers being the trapeze artists and just jumping from each other.
I like it. It does end with something here, and it says, as for who would win the talent show, it's a tough call. It would depend on the criteria set by the judges and the preferences of the audience.
Nice.
No shit. But both virtual machines and containers have their strengths and use cases, making a delightful competition filled with innovation and technological prowess. Nice. So actually, it came to the same conclusion you did, which is like, they're both great and it's going to be a great show. So, there we go. Our talent show between virtual machines and container has been hook, line, and sinker by ChatGPT.
Yeah.
Okay. Last shout out to Red Hat Summit. This will come out during Red Hat Summit, and if you're there, come find us. Otherwise, that's all I had for today. How about you, Bhavin?
Yeah. Let's wrap this.
All right. That brings us to the end of today's episode. I'm Ryan.
I'm Bhavin.
And thanks for joining another episode of Kubernetes Bytes. Thank you for listening to the Kubernetes Bytes podcast.